Hello. Alright, so for our first guided practice problem, let's take a look at it. So, what is the net force acting on a 26.5 kilogram box resting on the floor? So, let's say this is your floor, okay, then this is your box. Alright, so it has a certain mass, okay, and then this is your normal force, okay, so there, you can see it. So this is your normal force, which is F sub n, okay, so we have discussed it earlier, but the question is the net force acting on the floor, okay, which is, the net force acting on a 26 kilogram box resting on the floor. So we have this one, and then of course the other one would be this, okay, so this will be of course the weight, okay, of the box. So weight is, we can define it as capital W, which is of course mass times acceleration due to gravity, okay. So we already know that this is acceleration. So if you remember from the previous equation that I have shown, so F is equal to ma, correct? Or you can say summation of F is equal to ma. So since we're dealing with massive objects resting on certain things, so we're going to replace m with g, so a with g, so it will become this one, and then of course that would be weight, okay, or you can also weight force, something like that, depends, okay, but I prefer this one. This is for to have a more consistent what do you call this, naming or convention of variables, okay. So let's try to solve for it. So our given, according to the problem, we have a mass of 26.5 kilograms, is that correct? Okay, and then we have of course the acceleration due to gravity, which is 9.8 meter per second squared. Alright, then required is of course the net force, okay, or you can call it net force, something like this, F net, okay, it's up to you, okay. Then our equation of course would be we have two, so that would be summation of forces would be, look at this one, so you have normal force minus the weight, okay, or you can rewrite it on the other way around, okay, because according to the problem it's resting, okay, so you can replace either of these two. Alright, so what's next? Of course, you proceed on replacing W with the more proper equation, which is F sub n is equal to I minus mg. Then you can proceed on substituting, but first let's find W, okay, so let's solve that first, this one, okay, so let's do it here. So W is equal to 26.5 kg times 9.8 meter per second squared. There. So you cannot cancel any units, right? Because they're all different. So what you can do instead is to multiply. So you have 26.5 times 9.8. Alright, so what's the answer to that? 259.7. Okay, so our answer for this one is 259. Let's check again. 0.7. So you can copy the unit, so that's kilogram times meter, so that's kgm over s squared. Okay, or the SI unit for force, newtons. Okay, newtons. So this is newtons. Okay, so newtons. So 1 newton is equivalent to combination of kilogram times meter per second squared. Okay, as you can see, this can be derived from this variable, which will guarantee you, of course, that the equation used is correct. Okay, so this is your weight. Then after knowing that, return to the problem. According to the problem, it's resting. Okay, so it's not being disturbed or anything. And then if you recall the definition of the normal force, it's the equal force acting on an object resting on a perpendicular plane. So if I'm going to erase this one. There. Okay. So if you're going to look at this, it's not moving, right? So the applied force due to weight is equal to the applied force caused by the normal force. So that would mean your summation of forces would be, so this is our final solution, which is weight. So let's take weight first. So that's 259.7 newtons minus, so you can take the other direction with, since they are interacting forces. So if you remember the definition of the third law, so it will be the same. That guarantees that the object is not moving. So of course the final answer would be 0, which both accounts for the definition of the law of inertia, which is any object which is at rest will remain at rest. Alright, you got that? Okay, so let's have another example. Second example, according to the problem, we have an ice puck sliding. Okay, so we're going to draw, let's say this is your ice puck. Okay, and it's sliding on, of course, an icy surface going to this direction. And then according to the problem, there's a friction. So friction is the opposing force on any object that's moving in parallel to the plane. Okay, so from the diagram, this will be your friction force. Okay, so if the object is sliding to this direction, the friction force would be opposite of it. Okay, the next would be, of course, the weight of the ice puck. So that would be this one. Okay, so that's our weight. Let's place what do you call this, variable. So this will be your weight. Okay, then of course opposite of the weight is the normal force. Okay, then we have friction force, then we have, let's say, the applied force. Yes, so applied force is the one that's causing the ice puck to move or to accelerate. Okay, so let's try to write the problem. So of course the mass is here, the mass of the ice puck. Alright, so let's write the given. First one would be the mass. So according to the problem, the mass of the ice puck is 1.23 grams. Okay, which can be converted to kilograms. So just move 3 decimal places, so that would become 0.00 something, or you can write it as scientific notation instead. So that's 1.23 times 10 raised to negative 3 kilograms. There. Then the next one would be velocity. So according to the problem, it has traveled for a certain period of time. Okay, so it has covered the velocity of 4.56 meters per second at a time period of 4.26 seconds. Okay, then lastly, the force of friction, which is 0.0045. Okay, so the 0.00045, okay, which of course can be rewritten as 4.5 times 10 raised to negative 4. Unit of this is of course in newtons. So 1, 2, 3, 4. Okay, so this is correct. So our required, according to the problem, is the acceleration of the puck. Okay, so required is acceleration of the puck. So here's that. Equation would be utilizing the, what do you call this, fourth kinematic equation in conjunction with problems on forces. Okay, so first let's take the forces moving on the horizontal axis. Okay, so that's summation of forces on the x-axis would be equal to applied force. Of course, that would be the first one to write, because we know that it's accelerating. According to the problem, it's accelerating, so it must be the bigger number. Then to be subtracted to the friction force, okay, which has a certain value. Then this can be rewritten as force is equal to mass times acceleration, so that would become mass times acceleration minus the friction force, correct? And then since acceleration is the one that you're looking for, of course you can refer to your equations, kinematic equations, for the appropriate equation that you can use. So you can insert here initial velocity for ease. So let's do that. Okay, so what would happen is you're going to have 3 variables for given plus 1 for the missing or the required. So you already have 4 variables in total, so you can just rearrange it. Let's take this one first. Let me replace my whiteboard. Okay, so here I'm going to write the equation. So you're going to have v is equal to v sub 0 plus a delta t, correct? Then since what we need is acceleration, you're going to leave it on that side, so you're going to have this equation instead. Then replace the a here, which will become m is equal to v minus v sub 0 over delta t, correct, minus the kinetic friction. Alright, so this will be your summation of forces on the x-axis. Got that? So there, after setting that up, you can now solve first for the acceleration, and then finally the horizontal net force. So that's also being asked on the problem. So let's find the acceleration first. Alright, so this will be your final equation, but first let's find the acceleration. So let's grab I placed it on the wrong part, so it should be here. Okay, somewhere here. Alright, so let's do that. So for the solution, let's find acceleration first. So that's 4.56 meter per second minus 0 divided by 4.26 seconds. So our answer for acceleration, is, what's the answer to this? 4.56 divided by 4.26. There. So can you see it? 1.0704 or 1.07. Okay, so that's 1.07 meter per second squared. So you're going to notice under your units that would be your acceleration. The next, let's find the summation of forces on the horizontal axis. Okay, so the vertical axis is not being asked, so we don't really need to care much about that. So remember, when computing for individual axes, you solve for the individual axis. Don't combine them. Okay, so that's from the previous topic under projectile motion, right? You've learned that work on the individual axis. So same thing with forces. Okay, I'm just going to recopy this. So now we're going to find the summation of forces on the x-axis. Okay, so this will be, don't forget that always work on the axis independently, so don't combine into a single equation the equations for the x-axis and the equations for the y-axis. You have to separate them. Okay, so this will be applied force minus friction force, okay, which is equal to, what's this, MA minus, of course, the friction force. So this one, we already know this, so this will be the values that we have obtained earlier. So we have mass, which is 1.23 times 10 raised to negative 3 kilograms, multiplied by, we have here the acceleration, a meter per second squared, okay, minus, of course, 4.5 times 10 raised to negative 4 newtons. Okay, so this will be your summation on the x-axis. So what will be our answer? So okay, here, so I already placed it on the circle there. Can you see it? So here, so what's our answer? There, 8.66 times 10 raised to negative 4. Then the unit, of course, this is kilogram times meter per second squared, so that will be Newton. Then this is Newton, of course, this is Newton. Okay, so that's it. Let's proceed on taking another guided practice problem. Alright, so for our third problem, according to it, we have a box, okay, sliding on a frictionless surface. Okay, so here's our box, okay, which has a certain mass and is moved on a frictionless surface. Okay, so this will be our applied force. So that's it. So the given are as follows. So we have a mass of 12.5 kilograms. Then we have a force. So our applied force is 350 newtons. There. So from the problem, we have additional given after. So we have time, which is 5.98 seconds. And then lastly would be 350 meters per second. So let's say that's a certain velocity. Let's say that's v sub 1. Okay, so a nondescript velocity, which is 350 meters per second. There. So for our required, we have a lot. So first, what we need to find is acceleration. Then for the second question, what is being asked is the final velocity, so that's v. Okay, and then next question would be time, so that's how long will it take for the box to reach. Okay, so that's time. Let's place a nondescript time here, so that's time as t. Let's say t sub 1, so we can use delta t here. Okay, so for our equations, we have a lot, so I'm going to solve it one by one. So equation, solution, answer, equation, solution, answer, something like that. Okay, so for our first equation, we're looking for the acceleration, so this is easy. Okay, so F is equal to ma Okay, so since we're looking for acceleration, we can reframe this as f sub a is equal to m times a. Then divide both sides by m, since what we need is a, correct? Then for our first solution, so that's a is equal to f over a of f sub a over m is equal to, what's our f sub a? That's 350 newtons. Okay, you can break this down to kilogram meter per second squared to show the cancellation of units. kgm over s squared divided by, what's our mass? 12.5 kilograms. So cancel this. Okay, so what's our answer? So our answer for this one would be this, so that's 350 divided by 12.5 is here, there, so that's 28. Okay, so that's 28. What's the unit? Meter per second squared. Okay, so that's a. Alright, so we got a. Now let's proceed on finding what's the next item being asked. Let's look at the required final velocity. Okay, so we're going to use this 3 given, okay, plus of course the acceleration that we have. Okay, so of course the equation that we can use after knowing that we have to look for final velocity, we have acceleration, and then we have time as the given. Of course, include initial velocity, which is 0. You're going to have this equation plus a delta t. Okay, reframe it to the variables that we have. So final velocity is equal to initial velocity plus a, what's our t sub 1, which is our given. So this is already it. So let's proceed on finding what v is. So this is 0 plus, what's our a there? 28 meter per second squared, multiplied by time, which is from the given, so that's 5.98 seconds. Sorry, there. So cancel the units, so you're going to have meter per second as the remaining unit. So what's the answer for this one? 28 times 5.98. There, can you see it? Okay, so that's 167.44. Unit, of course, is meter per second. There, so I don't forget to box this one as well. Okay, then for the last one, so our third equation, according to the problem, we're looking for the time, okay, to reach the speed of 350 meter per second. Okay, so we're going to utilize, we're going to skip the time in this one and proceed on this one instead. Okay, so same equation, that would be the same equation, is equal to v sub 0 plus a delta t. Okay, in this case, we're going to utilize, we're going to find time here as per our required. So initial velocity would still remain 0, and then the velocity that we're going to use is the velocity from the given, which is v sub 1. Okay, then reframe your equation, so this will become v sub 1 minus v sub 0 divided by a, which is of course your a from the first answer, is equal to delta t. Then substitute, so this will be 350 meter per second minus 0 divided by a is equal to, this is supposed to be 28 meter per second squared. So cancel the meters, cancel the second, so you're going to have a single unit of second as your answer, which is what we need. Okay, then let's input that on our cycle. So that's 350 divided by 28, correct? There. So our answer is 12.5 seconds. There. So after finding this, that's it. You can now proceed on solving the self-paced practice problem. Try to explore some of the possibilities of the usage of the kinematic equations in solving problems involving forces. So that's it, and see you on the next one.